My name is Thorsten Lohmar. I'm working for Ericsson Research. I contributed to this 3PP work on definition of 5G media streaming. Of course, there was a bunch of other people involved. So today I have the pleasure to present what we have done in release 16, but please bear in mind, I'm just presenting what has been done. I've contributed, but it's contribution of many people. Frédéric can unfortunately not make it today, but yeah, that's life. So this is now an introduction to 5G media streaming. So we see today there is lots of HTTP-based streaming out. I would say majority of video services use HTTP-based streaming today. Of course, still there's other type of services ongoing. There's lots of things solved from the encoding, from video on demand, from live, from encryption, and so on. There's also kind of work ongoing and done on device synchronization for playback and so on. So, of course, one key question is, what's left? It's working. The interesting thing is, of course, when looking into the into BitMoveIn developer report from 2021. There are some interesting figures, very interesting to read. Last year, cost controlling was still kind of the high thing. This year, or in the last report, live low latency is more higher. So obviously, the industry starts now moving into, would say, moving from video on demand into normal live video into live low latency video to kind of get real, would say, experiences for instance, for sports services. The definition of low latency, it's of course interesting. At least when I hear low, typically I think in milliseconds, but here low latency, the majority of folks think that less than 3 seconds latency is enough, path latency is enough. Kind of followed by less than 5 seconds. Of course, there's also some people focusing on latencies below 1 second, but that's kind of the order of magnitude to kind of get reached in order to claim this is now low latency live. From the metrics, that's also interesting. The video services are monitored, and the last years, the video startup time was kind of key. Now bitrate delivered, so the quality and so on, it's more important. So by combining low latency and bitrates, it's of course then the question, how do you figure out at what bitrate can you stream and what is happening in the network, what is possible, right? Okay, but that was a bit of the background, the guiding things, what has been done in 3PP. Now jumping to 3PP. The 5G media streaming architecture. It has been done a new attempt in release 16. Of course, 3PP has been working on Dash, for instance, since 3PP release 9, so a very long time. But there, the focus was very much on formats and so on. Now for 5G, we started focusing on a framework type of approach, where the idea is to integrate a bit better between networks and the application provider. So here on the left side, it's the general application service layer architecture, which is kind of seen. The 5G MSD client is basically subdivided into two components, two functions. One is the media session handler, the other one is the media player. And of course, the peer for the media session handler is the 5G, so-called 5G MSD AF, which is more control related and so on. And the media player is kind of interacting directly with a 5G MS AS, which is a bit more like a CDN type of thing in order to get information. Here in this illustration, everything is kind of illustrated in one data network. Later on, I present some deployments, so what is possible to combine it and so on. Here on the right side, we see a high-level call flow, a simplified call flow, how it would work. So there is a concept called a provisioning session, what is basically running during the entire lifetime of a streaming session. this is basically just that the network is aware about, would say, something is happening. Then, of course, at some point in time, content can be ingested, so uploaded or live ingested into the 5G MSAS. So that's basically the CDN part. But the ingest is, of course, independent from the reception, from the unicast reception. So information is basically provided to the 5G MSD aware application to basically become aware about the service. And then in 3PP, there's some APIs defined, M6 and M7, to interact with the 5G MS client in order to activate the reception. In particular, the M6 API here on the left side should be used between the application and the media session handler. This is basically to start getting access to the information. And of course, the media session handler can then interact with media player in order to kind of get, for instance, a media streaming going, to get information from the media player, like kind of metrics reporting, like information and so on. The interesting thing here is in step 7, the media session handler in the client is interacting with the media AF, while so that's a 5G MSD AF, while the media player is interacting with the media with a 5G MS AS. And this is more kind of like that, control versus user plane. I explain later on a bit more about this. Yellow basically in this drawing indicates these functions are in scope of the 3PP specifications. It does not mean that you must follow the specifications here. So for instance, it's completely fine to basically use the formats from the 3PP specification and use, let's say, a 3DP dash player. But it's equally okay to focus just on the media session handler and kind of work with other type of streaming technologies. So in that sense, in particular, the video codecs and formats, there's a bunch of optional things. And the focus here is how to interact, and not that everything is kind of shipped in one box. Right. Kind of the interesting focus now is on these functions. The interactions with the media session handler and the 5G MSD AF. There is different type of interactions what can be done on this level. The interesting thing here is the 5G MSD AF can also interact with the NEF and the PCF. So these are two 5G specific functions. One is the network exposure function, in particular more for external interactions, while the PCF is more kind of internal for local interactions. So in particular, this M5 interface is kind of newly defined in 5G MS. M4 is very much kind of the normal existing streaming services like Dash or HLS. And M8 is a kind of not further specified interface. So it's basically, there's many information what needs to be exchanged. There is, of course, kind of the concept of an application on the UE side. So the focus here is what 3PP has done here is kind of to specify a new procedure for specific network interactions between the media session handler and the 5G MSD AF. In this drawing, of course, it becomes a bit of a question. Why can't this media session handler talk directly to the NEF? Why is the AF in the pass? Here it's a bit of a summary why this is done. This NEF API is more a backend API, which is used more, well, for service providers. It supports isolation of different backend systems. So when different type of providers use the same, interact with the same system, it's basically possible to isolate these two application service providers. But of course, it is really a backend interface because it allows visibility and operation of kind of all UEs. So there is no isolation between UEs. So it's really providing a holistic view on the resources from this application service provider. Of course, as an input here, something what is called service data flow filters are necessary. And here you need to bear in mind a 5G system or in an end-to-end IP pipe. There is lots of connection sharing ongoing. Of course, you may have a single application on a device, which is rather seldom. So quite often you have multiple applications on a device, so the connectivity is shared among multiple applications on one device. And of course, towards your application servers, there's also the traffic from multiple applications reaching the same application server. So the service data flow filters enable the unique identification of the traffic flows, which are then subject to be kind of interacted with from the system side. The M5 API between the MSH and the 5G MSAF, it supports, basically it's a front-end API. It supports the isolation of UI applications, so even isolation of UI applications on the same device. So it is really kind of designed in such a way that this application can only influence parameters of the own application and not really modify parameters from other applications on the same device or other parameters from other devices, right? And here the idea is that these UI applications also provide the service data flow filters and policy information towards the network when accessing CDN services or services on the network, right? So from the collaboration model, as indicated in 3PP, we have thought about different type of collaboration models. Of course, an existing model today is an OTT type of model where everything is deployed in an external data network. Equally valid is an telco CDN where these type of functions are deployed inside of the trusted domain. Trust domain does not necessarily mean kind of inside of the operator network or not. It's really more about the trust kind of who is managing these type of functions. So it might be even an external data network, even if you run it on premise of the telco, but probably outside of the trust domain. Yeah. And here, of course, the concept is the twin between 5G MSAF and media session handler controls the interactions from the application with the network, while of course the combination of 5G MSAS and media player, they provide the CDN type of connectivity. One thing is to consider when the installation, the 5G MSAF is deployed in an external data network. There's of course not so much trust in place, and in that sense, of course, the 5G MSAF needs to interact with the network exposure function using the NEF API. It's a bit more limited compared to the PCF API, but of course the PCF API, it's only kind of considered to be open up for trusted type of things. And this is kind of one of the key thoughts why we are mixing or thought about this mixed type of collaboration. So the idea is to enable access to network services without breaching kind of an end-to-end privacy context. So it's completely okay to run fully encrypted traffic then between the application server and the client. The application server is then kind of also outside of the trust domain, so in external domain. But in order to simplify the interactions with the network, the concept here, or one deployment, is that the 5G MSAF is operated, for instance, by the operator directly, in order to simplify the integration with other network functions to get access in an easier way from the network. One of the issues here is, of course, quite often there's a nut in the path between the client and external things. So in particular for IPv4, this has been done due to IPv4 address shortages. But of course, there's also security things on, so to basically hide a bit which device is doing what to kind of reduce traceability of the device and so on. Not sure how is it going to evolve with IPv6, because there these IP address shortages kind of a bit different. But that's of course something to consider, that quite often a nut is in the past and certain things become a bit complicated. There's additional collaboration scenarios defined. However, I think these are illustrating the key deployment scenarios, collaboration scenarios, which can be also used for the subsequent work. Now, from a functionality side, Release 16 is supporting different type of functions. There is video on demand and live support. There's uplink streaming support. There's different deployments like telco CDN or OTT CDN. In particular, of course, for telco CDNs, content hosting is important, meaning to upload content into CDN or into this system, or to basically make access to the content through that system. What is kind of interesting, and I will talk more about in the next presentation, is about this dynamic policies, for instance, premium costs or charging policies. This is very much about, let's say, when an SLA, a collaboration agreement, is in place between the operator and the application service provider. Then kind of it's not only a best effort pipe anymore, certain type of things become possible, but then of course other information is necessary, for instance, to identify the traffic flow. Beside that, there's also consumption and metrics reporting supported, and also network assistance to a certain extent. And then in Release 17, this is just about completing. There is extended data reporting. We've started working on integration combination with LTE broadcast or eMBMS or LTE-based 5G broadcast. And there's also this combination with Edge. For Release 18, what is already planned is identified is we need to work more on the combination with 5G and 5 MBS, so the 5G version of MBMS, because we're pretty limited in time, and therefore we said, let's do this in Release 18. There was already discussions ongoing about new protocols like HTTP3 Quick. Enhancements for live streaming is already identified, and I think this is now looking into the needs from the developer side or from the industry side spot on. New codecs will come up, background data transfer will look in, content-aware streaming, traffic identifications, and so on. So there's a bunch of things what is planned. Yeah. Right, just if you want to read more, there's a bunch of SA4 specifications. They are freely available. The main architecture, the general description of the architecture is in 501, 26.501. The protocols is in 512, and then kind of anything around profiles, codecs, and formats is then basically in these three specifications, a bit separating audio and video. Right. That was it, what I prepared as an introduction. I hope it was clear, but if there's any question, please